Hello and welcome to Chapter 8, in which we'll be talking about differential equations. All right, let's start right away with section 8.1, where we'll be defining differential equations. All right, our goal is just to introduce the concept of differential equation. Here's a definition. A differential equation, or DE for short, is an equation in an unknown function f of x involving, well, f of x and some of its derivative, f prime, second derivative, f double prime, third, and so on. A particular solution for a differential equation is one specific function, which, let's call it f of x, which satisfies the differential equation. A general solution for a differential equation is an expression which represents all particular solutions. All right, so I want to show you what all of these look like in the next example. So example 8.1.1, consider the differential equation f prime of x equals f of x plus 5x. It's a differential equation because it involves one function that we don't know, and it involves some of its derivative, in this case just the first derivative. All right, so I want to show that f of x, which is minus 5x minus 5, so that's a specific function. I want to show that it's a particular solution for star. So I need to check that this star equation right here is true for this function. So I'm going to look at the two sides of the equation separately. If I look at the left-hand side, LHS for short, left-hand side, that's f prime. So I'm going to take the derivative of the function I'm given, and that's just minus 5 plus 0, so minus 5. And then I'm going to compare it to what I get on the right-hand side, or HS for short, when I replace f by the function I'm given. So minus 5x minus 5, that's my f, and I add 5x, the minus 5x cancel, and I get minus 5. All right, these are equal, and so yes, f of x satisfies the DE. So it is a particular solution. All right, now I want to look at what a general solution would look like. So in B, I claim that f of x, which is c e to the x minus 5x minus 5, is a general solution for equation star. All right, so here c is an arbitrary constant. So it's not really a real function because I don't know what c is. But what I'm saying is whatever c is, I'm going to get so whatever value c I plug into here, I'm going to get a specific function here which satisfies the differential equation. So I want to check that for any value of c, f of x is indeed a solution. So I'm going to check it the same way I did above. It's just that now my function has this constant that I don't know. So here when I differentiate it, I get c e to the x minus 5. The right-hand side, minus 5x minus 5. I'm going to add 5x to this. It's going to cancel the middle term, and I'm going to get two sides are equal. All right, so for any value c, f of x is a differential equation. Is a solution. Is a solution for star. All right, so that's what a general solution looks like. It has some arbitrary constants that you could replace by any number you want and still get a solution. All right, so I want to use this general solution to find a particular solution for the differential equation we have with f0 equals 15. So whenever we're given values like this, that's called an initial condition for the differential equation. So I know that f of x will be c e to the x minus 5x minus 5. I just need to figure out what c is. So at x equals 0, I want 15, but what I have, I get c minus 5, and I want this to be 15, and so I need to make sure that c is 20. So to make sure that my initial condition matched the ones from the problem, to make sure that I have a function whose f0 equals 15, that forces my hand and fixes the value c to be 20. For any value c, I get a solution. So this is a solution for this differential equation with this specific condition I was given. All right, let me say differential equations seem a bit weird at first, but they're super important. When modeling real life situation, you often start by translating the setup into a differential equation that you must then solve. So there's um, tons and tons of mathematicians who work on differential equation. Solving them is super important. It's not always easy. It depends on the type of differential equation. So in the next section, we'll learn how to solve a certain type of differential equations. Afterwards, we'll apply our method to real life problems. All right, so next video, we'll start talking about separable differential equations.